All right, now we're going to start talking about horizontal asymptotes. We've seen these in most of the prior examples because pretty much every rational function, almost every rational function that you'll see will have a horizontal asymptote of some sort. Not everyone, though. We're going to talk about that in a little bit. So our horizontal line, y equals a number, okay, is a horizontal asymptote for the graph of f of x if either or both of the following are true. Either the function approaches some value, approaches that value b as x goes to infinity. So in other words, as we go off far to the right, or f of x approaches b as x goes to negative infinity. And so here in our picture here, we have f of x approaching 1 as x goes to positive infinity and f of x approaching 1 as x goes to negative infinity. Now there are some functions that have will be approaching different locations as you go positive infinity versus negative infinity, known as logistic equations. You're not going to see those in this class, but they might look like this. You might have, roughly speaking, like this, and you've got a horizontal asymptote up here, and and then another one down here. I didn't draw it real well, but you're not going to see those in this class. All right, so how do we find these horizontal asymptotes? That's the next question. And so thankfully that's pretty easy. We just look at what the degree of the numerator is versus the denominator. So if the degree on top is less than the degree on the bottom, then our horizontal asymptote is going to be y equals 0. This is the x-axis. If the degree on the top is the same as the degree on the bottom, then we're looking at the horizontal asymptote being the ratio of the leading coefficient. So the top, the numerator leading coefficient, we're going to call that A. The bottom or denominator leading coefficient, we're going to call that B. So our horizontal asymptote would just be A over B, y equals A over B. And if the degree on the numerator is higher than the denominator, you're not going to have a horizontal asymptote. Now, unlike vertical asymptotes, a graph can cross a horizontal asymptote. You can cross it several times. So just be aware of that. So for instance, here we've got ourselves a rational function. This looks a lot like what we had before. We should start by factoring out some common factors, right? Nothing to factor out in the numerator, but I can pull out an x squared out of the denominator, right? And that helps me see right away that we need to throw out 0 and -2 from the domain. And again, I'm going to mess with the scale here because I need it more stretched out. There we go. Okay, so we're going to have, there's no holes, right? No common factors top and bottom. So we're going to have vertical asymptotes at 0 and at -2. There we go. Close enough. Y-intercept, there's not one because x equals 0 is not in the domain. Vertical asymptotes, we already said x equals 0, x equals -2. And then we might say, what's not in here, what's our x-intercept? And we would say, well, where is the numerator, 1x plus 6, where's that equal to 0? That's going to happen when x is -6. So that's off screen on this one, but we do know that it's there. So -3, -4, -5, -6. So there. No, it's no longer off screen, right? And we also want to ask, well, is there a horizontal asymptote? And we're going to say, okay, well, what is the numerator's degree over the denominator's degree? Well, the numerator degree is 1, the denominator degree is 3, so that means it's going to be the x-axis, y equals 0. Okay. Now we can graph this, we could sketch this all out, we could pick a couple of points, we could say what is the function value at -1, and we would say, let's see, -1 plus 6, that's 5, -1 cubed, that's -1, and 2 plus 2, so that would be 5. So we're looking like here, and we know we can't cross the x-axis or the vertical asymptote, so it's doing something like this. And we can do the same thing. We could plug in x equals 1. We would have y equals 7 over 3, which is about 2 1/3, right? And so we know something like that. And then we could plug in, like, let's say x equals -3. So we would have -3 plus 6 is 3. -3 squared is -27. Plus 18, and that's just a negative number. I don't really care what it is. I just know it's something negative. So we know it's going to be doing something like that, but then it is going to go through the x-axis. So I don't want to plug in a whole lot of numbers here because we're going to go over time, but let's look at the function on GeoGebra. Y equals, so, all right, we got x plus 6 over x cubed plus 2x squared. All right, and let's see here. So first off, there's the part I was like, wait, where is that part that we did in the middle between -2 and 0 on the x-axis? Well, there it is. We see that. And here, we know that it crosses at 6, right? If I click on here, it should tell me that I have a 0 at 6, a root, and this is a local max. So it's basically coming just over the x-axis and then going back towards the x-axis. So we can go fix that in our sketch. We can just basically say, you know, we're doing that, basically. All right, so that's all that there is to this one. We're going to do a couple more examples for horizontal asymptotes, though.